chemistryinventor.com.
Screencast 12.16, a little bit about bond energy. Every chemical reaction involves breaking bonds and making bonds. And can't we just figure out the energy of a chemical reaction, that change in energy, simply by comparing the bonds that are broken and the bonds that are being formed? Let's try to do that. Well, it takes energy to break bonds. That makes sense, because if it released energy to break bonds, well, they'd just be breaking all the time. You've got to have some kind of glue holding them together. You apply that energy to break them. So that might seem weird, but that does make sense from that point of view. Believe me, I've gotten confused about it at times. I don't know what that was. Let's keep going. Okay, let's give some bond energies. For hydrogen, oxygen, that's the bond energy of both of those bonds, that double bond, and the oxygen and hydrogen bonds. So they have various strengths. Not surprisingly, the double bond is the strongest. Let's use this data to predict the energy output from burning hydrogen. Balanced chemical equation is going to be needed. We'll add up those bond energies and predict what's going on. There's our balanced chemical equation. So let's draw those molecules. 2 hydrogens, good, they're both going to break. 1 oxygen double bond, that's going to break. We'll form that water molecule. Looks like 2 oxygen to hydrogen bonds, and there's 2 molecules that form per cycle here, so let's draw both of them. I guess 4 oxygen to hydrogen bonds. So it's going to take 436 kilojoules per mole to break that bad boy. 436 to break that guy, and okay, so it's 2 times that, and about 500 to break that big double bond there. What do we gain from it? Well, it liberates that one, that one, that one, and that one. 4 times that. So it looks like this thing is going to be overall negative 486 kilojoules. It's per mole. So you burn hydrogen and you can warm your hands by that fire, and that does make sense. So this might be perhaps the best way to think about energy from a chemist's point of view. Bond breaking and bond making. Burning 4 grams of hydrogen will release 486 kilojoules of energy per mole. That's 18 grams. Wait a minute. 4 grams of hydrogen. Yeah. It's per mole, but we have to start with 2. That's why I used hydrogen, because there's 2 moles in the balanced chemical equation. Fine. But since that 486 kilojoules, let's convert that to nutritional calories. It's always important to compare this to the real world, because those joules are so small. We're really only releasing about 100 nutritional calories, the same amount that's in a can of Coke. Okay, that ends, at least for most students, the energy unit. The next unit is reaction rates.